This was my second week teaching at UCLA. It's pretty cool.
Right.
Yeah, second week. Oh, see now I think YouTube Shorts is working. I think I see something.
Okay.
Do I? Yes, cool. We're up. Nice. All right, sweet. Yeah, it was my second week teaching at UCLA. I think the lecture went well. I had people come by office hours, which I thought was very cool. And I asked them, like, do you guys like the lecture? They're like, yeah, we love the lecture. I'm like, cool, dude. Nice. Big fan of that.
Your style of teaching is good, so
Yeah.
you're gonna love the taste.
Yeah, they're cool. Smart kids. We went over 1D kinematics today. You took physics, Grim, didn't you, when you were in high school? You're supposed to still be in high school. You took physics, right? Yeah.
Mhm.
Do you remember like doing like the equations of motion and stuff too?
Mhm.
Someone says they're getting heavy lag. Yeah, I don't know what's going on, honestly. Just if I can just get the stream running, I'll be happy. Because OBS has been giving me like 9 different reasons to not want to exist or live today. So
Yeah.
y'all let me know if it's doable. But yeah, Grim, we did kinematics. We did like the like velocity and acceleration and position. You remember those terms, yeah? Yeah. Okay. Well, go back to school, please, Grim. Like, why are we delayed with going back to school? I thought you were supposed to start going back to high school in like December.
I'm going back to school. Don't worry.
You are? Okay.
Yeah.
I mean, don't wait too long. You know, no time like the present. Do it as soon as you can.
I'm gonna do it as soon as I can. Finish that one semester I'm missing, and then just
good.
Boom.
Then you can start going to college and stuff. That's where the dope stuff is, man, dude. That's dope, dude.
That's dope.
You want to go to college? You're smart, Grim. I was telling my sister that the other day because I was talking to Ramiro in my car while we were like driving down. She's like, "Who is that?" I said, "Oh, that's Ramiro. You know, that's one of my students." And I'm like, his brother is really, really smart, but you know, for whatever reason, keeps getting caught up in the wrong people, and so now he's kind of kicked out of high school. So I'm trying to get him to go back to high school.
Yeah.
Yeah.
It all started with my homeboy Chris.
Yeah, I mean, it's kind of a lesson in life.
I started skipping more. I started just going out more.
I know. Yeah, you got to watch out. You want to
people.
You want to be friends with people that bring you up, not drag you down. You know, and sometimes that's a tough conversation to have with people. To be like,
hey, but I don't regret it. I got my girlfriend.
Again, yeah, I don't think you should ever regret things, but at least learn. You know, I say a mistake is not a mistake unless you do it twice. So if you keep doing like the wrong thing, then that's a mistake. But otherwise, it's an experience. So I know it can be hard to tell certain friends that like, hey, we can't hang out anymore because like my life is going in a bad direction. But if they're really your friends and really your homies, they'll respect that and be like, hey, yeah, I understand that, you know, our friendship isn't serving you the best. So we can still like talk to each other, but like maybe just not hang out as much, you know? I don't know.
I've had to have that conversation like 5 times with people already.
Yeah, I mean, you just gotta tell people like, yo, I gotta do me. I gotta, you know, go to school. I gotta get good grades, all that fun stuff, and I'm cool to hang out with you guys afterwards. But like, let me lock in and just get this done first, dude. You only got a semester left. Just fucking finish that, dude, and then you can do whatever you want.
Yeah. Then I'm free.
Dropping hella frames. I'm sorry, guys. One sec. Let me kill the Discord stream then. Sorry, I gotta kill Discord. That's the priority.
Damn.
Yeah, I gotta kill the Discord.
Killing Discord is crazy.
I forget
Discord
how to
day
like.
one.
I forget how to like remove sources and stuff, but maybe this is fixed. No, I'm still losing 20% due to rendering frames. Really? That's so dumb. One sec. Let me disable preview on that. Yeah. Oh, better. We're at 4%. Okay. Frames looking better. No, still bad. 5%. 6%.
Huh?
I'm telling the people on Twitch if they're noticing if it's getting better or worse. I think it's actually slowly getting worse. Drop frame. Oh man.
Hey, Gold.
What's up, dude?
Spanish class, ready?
Are you gonna tell me something in Spanish? We're gonna learn something in Spanish today?
Yeah.
What are we gonna learn?
That is pendejo. Decipher that.
You're an asshole. That's what I know pendejo means. Okay.
Yeah, basically.
All right, cool. Y'all let me know on Twitch if it's unbearable. This is the third time I've restarted my PC. I really don't want to have to do it again. Like, kill the whole stream.
You're overloading your PC.
Buffer size is like 7 seconds with 15 seconds later. 300 skipped frames? Excuse me, that's terrible. One sec. That is, yeah. Let me see.
That's it, bro.
What's up with our playback today?
Okay.
That's not good.
Oh, bye, Gold.
All right, see you, Grim.
I'm gonna go do some errands.
You want to come back to go?
Yeah, we're good. Yo.
Yo, what's up, Ramiro, dude? What's going on? Yeah, it's not great.
What's going on? How you spend your birthday?
Good, dude. Good. My birthday was great, dude. I appreciate it, dude. Appreciate the phone call. That was really nice. What's up, Ski?
Of course.
Nice, dude. Yeah.
I took a couple shots.
You took a couple shots for me, dude? That's really nice. I appreciate that. Sick. Long time no see. What's up, Ski? Yeah. All right, I'm gonna start the stream off. I gotta. People have been waiting for a little bit, but always good to hear from you guys and everything. Let's start things off. Welcome to All Stars. My name is Dr. School of Sexual Education. Streams helps you out. Math homework, science homework. All sorts of fun things. Tell me if the stream's looking a little bit better. I'm at least not seeing so much dropped. Now my network is dropping though. Damn. Can't win today, can I? Okay, but at least bitrate wise. Well, yeah, I could share on Discord, but then the issue is that then it's going to really crash the Twitch. Yeah. Okay. We're going to try and do our best. There's only so much I can do. I can't believe the bitrate's only 1400. That seems a little low. One sec. Let me check my internet speed. What's going on today with internet speed? See, that's decently fast. Yeah, 350 down? That's okay. Let's see what the upload's doing. It's normal on YouTube and TikTok, or maybe not. It's working on YouTube. Yeah, that upload speed's kind of all over the place. Okay. Yeah, okay, just for whatever reason, my upload's not doing too well today. That should get better. If it's not, I may have to, like, reset my router. Yeah, I don't know. Alright, we'll go through things, and if things hopefully get better. It's working on YouTube? Okay, cool. Alright. Watch on YouTube, then. Please. Alright, let's see. And then let me make sure TikTok's working. The issue is Twitch. Okay, well, Twitch is just being dumb then. So, if you would like to watch as well on YouTube, you can do that. That should be working out fine. I don't know why Twitch's servers are busted today. One sec, I have to select two objects that are the same shape. This is always too funny. These things are both dodecahedrons. Yeah. I don't know why there's something up with Twitch today. But if you'd like to watch on any of the other platforms, while we wait for, I guess, Twitch to start playing nice again, here, I'll give you the YouTube stream as well. So I think if we go to, like, YouTube here, then we go to our profile, go to our profile. Oh, see, this looks fine. Yeah, okay, so, like, Twitch is just messing up. There you go. There's the YouTube if you want to go watch that. And then we're also on TikTok as well. So if you'd like to watch on TikTok. I don't know why Twitch is not working today. It happens. But it's okay. Oh, things want to load today. There we go. Yeah, and here we're live on here. I think if I click on this, this should say that we're live. Yeah, there we go. There, and that's also our TikTok. You can go watch on that as well. Everyone migrate to TikTok at some point. Yeah, maybe. Okay. Appreciate you guys being patient while we work through the technical issues. All right, let's see. Yeah, because man, dude, even my Discord is like taking forever to load images. Wow. Okay. I'll never migrate to TikTok. Yeah. I think Trump put another 70-day extension on the ban. I don't know. All right, let's see. What's up, CDCB? All right, first question here comes from Swa. We'll see if Swa's in here. All right. It says, if log base 3 of 2, log base 3 of 2 to the x minus 5, and log base 3 of 2 to the x minus 7.5 are an arithmetic progression, determine the value of x. Well, this is pretty cool. So I believe arithmetic progression here means that, for instance, if we have an A0, an A1, and then an A2, if these are like different terms in the sequence, then A1 is equal to some number plus the previous term. And if we wanted to write this out in like a generic form, we would say a n plus 1 is equal to a sub n. So the future term is equal to the present term plus something, some constant here that has to stay constant through every single thing. Yes, what's up, Sensation? I see you on the TikTok. Yeah, you're good. And you should be able to see it there in the chat, right? Yeah. Okay. All right. So our first term, which I'm gonna call like a sub 0. I know you guys are gonna hate me for starting things at 0. That's log base 3 of 2. A sub 1 was log base 3 of 2 to the x minus 5. And then a sub 2 is equal to log base 3 of 2 to the x minus 7/2. Wow. This is very interesting. Okay. So I want to know what's the difference between these things, I think. I'm tempted to like look at a log rule type thing. The issue is that we don't know what the log of something minus something is. We know what the log of something divided by something is, and that's equal to 2 separate logs. That would be log A minus log B. But this is they're subtracting inside the log. If they're dividing inside the log, I can separate them into 2 separate logs subtracting outside of each other. But as it stands right now, well, here, let's just say this is equal to, yeah, let's say this is equal to A0, all right? So if we were to do the exponential form of this, this would be the same thing as 3 to the A0 is equal to 2, okay? And then this would, for instance, be 3 to the A1 is equal to 2 to the x minus 5. And then this would be 3 to the A2 is equal to 2 to the x. Minus 5. And then this is minus 7/2. And we want x to be some value such that this is like going up by a constant number. So, I mean, as this stands right now, right? Yeah, A is equal to, This is a not. You can't just sub this in though. Dude, what? Does anyone else see how to do this one? I don't think I do. This is weird. Chicken Jockey, dude. Flint and Steel actually put a real problem up, but Chicken Jockey, dude, what? The fucking flowers questions. It turns in a geometric sequence, does it? But then we say it's an arithmetic sequence, though. So that's my question there. Right? I don't know. Feed it to the GPT. The log turns multiplication into addition. I agree. But the issue is that these things are subtractions, like, inside. Right? Yeah. Let's feed it to the GPT beast. I'm curious. Yeah. Is even ChatGPT like not working today? Come on. Okay, here we go. Use the theorem where in arithmetic progression, A2 is equal to A1 plus A2 divided by 2. Oh, is that a definition of arithmetic progression? Sorry. I just thought arithmetic progression meant it's an arithmetic series, but I could be wrong. Yeah, no. Oh. Oh, this is kind of new. I don't think I've seen this. It's a sequence of numbers such that the difference between any succeeding term remains okay. I kind of like this. 1 sec. Yeah, good. Thank you for ever pointing me in the right direction with this. I think I see this. Okay. So, it's A1 plus A3 over 2. Well, this says that, no, I think it is, okay. Okay. All right. So we're saying that the difference between, for instance, again, I'll start this at 1. I'll say A1 is equal to log base 3 of 2. A2 is to log base 3 of 2 to the x minus 5. And then A3 is equal to log base 3 of 2 to the x minus 7 halves. And so, yeah. In an arithmetic progression, 2b equals a plus c. That's cool. Yeah. So what they're saying is that if something is, for instance, going up by a constant here, this is like plus some value c, and then going up here by another plus some value c, then this must be the average of the term before it and the term afterwards, if they're all going up by a constant. We can see it this way. Let's say we did 3, 7, 11. This would be arithmetic. Do you see how this is plus 4, to go from here to here, and then to go to here from here? And that 7 is the same thing as the average of these two. So 7 is the average of 14. Or 3 plus 11. 3 and 11 averages out to 7, because 3 plus 11 is 14 divided by 2. Yeah, very cool. I didn't even yeah. So since this thing had plus c happen to it, and this thing had plus c happen to it, this is the average of these two. Okay, very cool. So we can say log base 3 of 2 to the x minus 5 is equal to log base 3 of 2 plus log base 3 of 2 to the x minus 7 halves. And then this is all divided by 2. This is where things are cool, because if I have, for instance, 2 logs that are separate and adding to each other, that's the same thing as a single log where they are multiplying each other. So this is the same thing as log base 3 of 2 times this one, which is going to be 2 to the x minus 7 halves. Okay, let's just say like this one's here, this one's the green one. Okay. and then this is all divided by 2, and then this is still log base 3 of 2 to the x minus 5. Okay. Yeah, the live's working fine on YouTube. Okay, good. I don't know what's going on with Twitch, but yeah, I'm dropping super high frames on Twitch. I don't know why. Okay, so now if we're multiplying this through, okay, that's the same as log base 3. So 2 times 2 to the x is the same thing as 2 to the 1 times 2 to the x. And if you're from exponent rules, this is the same thing as 2 to the 1 plus x. So we have 2 to the 1 plus x minus 7 all over 2. Yeah, I apologize if the Twitch is... Yeah, something's up with Twitch's servers today, but that's why we stream on all 3 services. So if you want to check it out on either YouTube or TikTok, those are the links for it. Tell me if you can read them, Azer, Zoltania. I don't know why Twitch is messing up today. But I've already restarted my PC so many times I can't keep doing it. Okay. So, oh man, this is very interesting. I need to multiply this on this side, right? Get rid of this. So now I have 2 log base 3 of 2 to the x minus 5 is equal to log base 3 2 to the 1 plus x minus 7. Which... Man, this is messy, though, because now we have x in the exponent. I really don't like that. I'm tempted to just guess and check, but I never like that being the main way to do it. I think eventually what we have to do is we have to pull this 2 up top, okay? So, with log rules, if you have multipliers out front, they can come up to the top as exponentials, and vice versa. If there's an exponent up here, you can bring it out front. Yeah, exactly. I agree with that, Saba. Right, so 2 to the x minus 5 squared is now equal to 2 to the 1 plus x minus 7. Wow. Okay. Next step, I believe, is to expand this out, right? So that's going to be 2 to the 2x minus 2 times 2 to the x times minus 5. Or, sorry, so plus. But, yeah, I have the minus in there. Okay. Because this is the same thing. So a plus b squared is the same thing as a squared plus 2ab plus b squared. So the first thing squared, 2 to the x squared is 2 to the 2x. And then it's 2 times this, and then finally plus 25. And then this is equal to 2 to the 1 plus x minus 7. Okay. Okay. 2 times 2 to the x is also 2 to the 1 plus x. So we have 2 to the 2x minus 5 times 2 to the 1 plus x plus 25. And actually, let's move this over. So we're going to say plus 32. And then let me move this one over as well. So I'm going to say minus 2 to the 1 plus x plus 32 is equal to 0. All right. Common things here. This is the same thing as one of these 2 to the 1 plus x's, and this is negative 5 of them. So that's going to be negative 6. So 2 to the 2x minus 6 times 2 to the 1 plus x plus 32 is equal to 0. Wow. I see some factors of 2. Right? I can divide a 2 out of everything here, can I? Well, no, not really, can I? Yeah, no. I'm tempted, but no, there's really just a 1 in front of here. Ugh. Okay. To solve this explicitly, Okay, I like that, Saba. Yeah. He's saying let's redefine 2x. This is very complicated. So let's let u equal 2 to the x. Okay. So 2 to the 2x is the same thing as 2 to the x to the second, which is equal to u squared. All right? And then 2 to the 1 plus x is equal to 2 to the 1, 2 to the x, so that's equal to 2u. This is a quadratic eventually. Anytime you see something where you're like, oh, look, I got higher powers in the exponent, and then, like, lower powers, and then lower powers, you can try to make this, exactly. And, yeah, that's what we did here. So this is going to become u squared minus 12u plus 32 is equal to 0. Okay. This is the same thing as minus 4 and minus 8, because negative 4 and negative 8 multiply to positive 32 and add up to negative 12. So you're going to get u minus 4, u minus 8 equal to 0. So my solutions are either u equals 4 or u equals 8. And let's remember that u is equal to 2 to the x. So 4 equals 2 to the x. So the solution there is x equals 2. Or 8 is equal to 2 to the x. So we would say x is equal to 3. Which I think 3 is what we want. Right, okay. And yeah, what you want to do eventually is check to see, wait, do any of these make sense? So we said x equals 2 or x equals 3. Exactly. If we check, we got to plug it in because there are some domain restrictions for log. If I plug 2 into here, I get 2 squared, which is 4, and 4 minus 5 is negative 1. You can't have that. It doesn't work out.
No.
Because that's the log of negative 1, which is undefined. 3, however, does work, because 2 to the 3 is 8. 8 minus 5 is 3. Cool. Love that. That's okay. Same thing here. 8 minus 7 halves, going to be above. So, yeah, your final answer here is 3. Wow. Nice. Happy thought.
Well done! Well done!
And 2 is not an option. Thanks, Saba. I appreciate you coming by and giving us some help there. Yeah, I needed a little bit of inspiration. Was cool. Again, I realized that an arithmetic progression is that you have to keep adding a constant to the next term. I didn't immediately recognize that the middle term has to be the average of the term before and after it. That really helped out. And I think identifying that, hey, they're giving me 3 terms, so I need the middle one to do something with the outer 2. Pretty cool. I thought that was a very cool question. Okay. Let's see. We have a couple. One, Flint and Steel. You submitted a question. I think I need to put like what platform people submit their questions from so that I can remember. But Flint and Steel, if this is your question and you're still in the chat, can you please let me know which one you need help with? 7, 8, 9, 10, 11, or 12. Otherwise, there was another funny question that someone sent in our web link, which y'all hit me with the weird math questions, dude. This one, yeah. Yes, that one works as well. So let me know which one you guys are on, or if you're still in the chat, Flint and Steel, and I'll help you out with one of these. Let me see real quick if I can solve the Facebook soccer mom question. These are always fun. Make sure to count the petals. Yeah, the minions have 1 less balloon, right? That one messed us up last time. Okay. Alright. Could we solve this? Okay, so 3 roses add up to 60. I think that's pretty simple, right? That means one of these things is equal to 20. Yeah, they're trying to mess with us. Look at this. With the double dandelions. Okay. If we call this thing, let's call this thing like y. Then we know that 20 plus 2y is equal to 30. So that tells me right away that what we call y, like a daisy? I call it a daisy. I'm gonna say blue flower. Blue flower is equal to 5. Okay. Now this is the tricky thing here. So now they have 5 minus what I think is 2 sunflowers. Orchid? Yeah, maybe an orchid. So we can call this thing z, for instance. So 2z is equal to 3. Okay. That tells me that z, which is equal to a single sunflower, must be equal to 1. Okay. Yeah. Nice. Okay, so then we do this one. This is 1 plus 20 times 5. And I think what people sometimes get wrong here is the order of operations. Yeah, they get you with the PEMDAS or the BEDMAS, whatever you guys call it. Yeah. So you have to do this first. 20 times 5 first is 100. And then 1 plus that gets you the 101. Nice. Yeah. That one's not too bad. Cool. Flint and steel. If you come by the chat, let me know. And I'll, because I don't know which question you want me to go through, but I can go through all of them later. Let's see. We had a couple of these. Let's see. Let me do Shantrix's. Let me do your Shantrix. And then we'll work on to Reki. Reki's here. Yeah. I can try disabling the if I disable the Twitch and then restart it. I wonder if it'll mess it up again. I'm gonna try it. See if it kills it. I don't know. All right, we'll see if it comes in. Let me get this question in first. Bum, bum, bum. It's trying to stop it. I don't know what it's doing though. Okay. Amir, Bai, Cindy, and Derek divide n coins between them so that each receives a whole number of coins. I'm glad they at least used A, B, C, D as the names. That's really nice. Big fan of that. Okay. Amer receives 1/3 of the total coins that Bai and Cindy. Bai receives 1/5. Is this going to be like it has to be divisible by 3, it has to be divisible by 5, and it has to be divisible by 7? I think that's kind of that is a key point here. The whole number of coins. That's gonna affect something here. Okay. Oh, you do have the answer though, at least. Okay, that's cool. Here, then let me try. I'm gonna see if I can hit the Twitch again. If it'll play nice with me. Okay. Yeah, Seth is always good with the number theory stuff. So A plus B plus C plus... No, Twitch is still fucking up with frames. That's ridiculous. Okay, I'm gonna stop the Twitch stream. It's just not working today. A plus C plus D has to be equal to N. So A is equal to 1/3 B plus C plus D. b equals 1/5. 1/5 a plus c plus d. And then c is equal to 1/7 ABD. If n is less than 100, what is the largest possible value of n? Okay. So n is less than 100. What is largest n value we can have? Interesting. Okay. Well, I kind of see something here. So, if I were to rewrite this by putting a 3 on both sides there, I would have that 3a is equal to b plus c plus d. And then 5b is equal to a plus c plus d. And then 7c is equal to a plus b plus d. And now look what happens. If, for instance, in this equation, we replace b plus c plus d with 3a, that gets me that 4a is equal to n. Okay. With this one, what's up, Reki? ACD is equal to 5b. That gets me that 6b is equal to n. And then this gets me that 8c is equal to n. Right? So a has to be n divisible by 4. B has to be equal to n divisible by 6. And C has to be equal to n divisible by 8. And n has to be less than 100. So maybe we should look at values of n that this thing works for. Just straight off the bat, right? And I guess we don't know anything for D, though. Oh, we do know an additional bit of information here, though, right? We know that A plus B plus C plus D must be equal to N. Right, yeah, but here's the additional thing here, right? I can now figure out what D is. Because N over 4 plus N over 6 plus N over 8 plus D must be equal to N, right? So, man, I need a common multiple of these things. 24, I guess, right? So 6N over 24 plus 4N over 24 plus 3N over 24 plus D is equal to N. So what is that? 13N over 24 plus D is equal to N. So D must be equal to 14N over... 11N. So D equals 11N over 24. Right? Because they all have to add up to eventually to N. That's a weird one. I think that's going to put some serious restrictions on things. Okay. I don't need to worry about the 4, right? Because if it's divisible by 8, it will be divisible by 4 as well. I agree with that. This one is going to be weird, though. I could write the multiples of 6 and 8 up to 100, but also this. I think this kind of puts the linchpin in what n can be. Because 11 24ths? That's really weird. Right? N over 4, N over 6, N over 8. So that's 6, 4, 3, 7, 13. Yeah, 11. I don't know what n can be such that this is a whole number. Right? Because, what, you have 24, 48, 72, 96, and there's no way for 11 times n to equal one of these things, right? Yeah. So wait, is this even possible? Uh-oh. Plus B plus C plus D. 4, 8. Yeah, right. 6, 4, 10. 13. 11, right? Yeah, I don't know how D can be a whole number now. Oh, D doesn't have to be whole? No, we said each of them receives a whole number of coins. So I think D does need to be whole. Because isn't D the number of coins that they receive? Right? A is the number of coins. That they receive. I think D does have to be whole. Anyways, let's see, for instance, multiples of like 8 and 6 up to 100. So I know for 6, and let's just start something high, right? Let's start at 60. So you got 60, 66, 72, 78, 84, 90, 96. And then let's start with the 8s. Yeah, D does have to be whole, right? Yeah. I don't know how that works then. 64, 72, 80, 88, 96. So 96 looks like a candidate. So let's say it was 96. I'm just curious. Okay. So if we have 96, then 8 times that has to be equal to 96. So we would say 8 times 12. So this is C. 96 times 11 over 24. Oh, I think it is actually. You are right, Stantrix. Yeah. It does work, actually. Yeah. Because 96 over 24 is 4 times 11. Yeah, okay, so let's watch this. So 8 times 12 is C. That's 96. 4 times 24 is equal to 96. So that means this one is... What's up, P127? That means this one is A, right? And then 6 times 16, that's equal to B. Okay. So let's see if it makes sense for D then. Okay. So 12 plus 24 plus 16, that's going to be 52. Which means that D then needs to equal to 48. Which I think does work out. Because, yeah, let's pull out the calculator and see what that is. That's cool if 96 is just it. I mean, they said the biggest number, so I knew we had to like kind of check kind of high. Yeah. So 11 times 96 divided by 24 is equal to 44. Yeah. So that actually does work. Okay. So, I think D is 44 instead of 48. Yeah, let me see where I got that from. Sorry. So, I said 12 plus 24. Oh, no, wait. 12 plus 24 is 36. 36 plus 16, yes, is 52. Oh, but we're going up to 96, not to up to 100. So D is equal to 44. Yes. Okay, cool. That works out. So I think the largest possible value of N is 96. Is that correct? Here, let me download Swaz real quick. This was Swaz. Yes, it is. Nice. Cool question. That was a good one. There was a little bit of number theory stuff in there. I think we got kind of lucky starting at the top and going down. Nice. Pascal Cayley for Ma. Yeah. Oh, I see. Question 23, the answer was 96. Very cool. Is this for the most recent test you took, Shantrix? Is this the most recent one? Yeah, let me make sure TikTok's not doing anything weird with me. Like, requiring me to figure out whether there's hats or stuff. No, we're still good. Okay, cool. Oh, that's why the solutions aren't out yet. Very cool. CDCB. Which one was your question? CDCB, by the way. Was your question, was it one of these? CDCB? Oh, you're Skeeg. Okay, Skeeg. Nice. Okay, what was your question, Skeeg? Oh, I think you submitted yours from a couple days back, right? Series. Okay, yeah, let's do a series question. I like series. Okay. Which of the series converges absolutely? Which converges conditionally, and which diverge? Give reasons for your answers. Okay. conditional convergence, I think, is where like the absolute value converges, but the regular one does not. Is that correct? Let me Google this real quick for you. I need to see it. Okay, a series that converges, but the series is absolute means only because of the alternating sign. Okay. Right, because I always like the alternating series test. Yeah, here we go. Got you. This is kind of cool. Okay. Yeah, go if you want to submit a question. The best way to do it is to use our link down there. It's actualdiscord.com/submit. And if you submit a screenshot there, we'll go through it soon. Right, okay. So what I can initially just do here, right, is I know that this converges conditionally, at least, by the alternating series test. And what that says is that if your series is alternating between positive and negative, and it is always decreasing, which this is because it's 1 over polynomial that's positive, then the thing converges for sure. So this does converge conditionally, at least, by alternating series. It's okay, Sensation. Go Joe Gatto, go Jatto, you can see it now. Sometimes, yeah, reading is hard. I get it. All right. The other way to then do this, so if we were to prove it converges absolutely, all right, the Riemann hypothesis. Yeah, sure. So yeah, Motion. If you take a picture of your homework question and submit it using the website, we'll do it pretty soon here. Just hang around. So I could do this by the comparison test. Okay, by comparison. Okay. If we take the absolute value of this, right, that gets rid of this whole thing. So we no longer have the alternating part, okay? And we just have 1 over n squared plus 2n plus 1. All right. I know that the series from n equals 1 to infinity of 1 over n squared converges. And I know this by what I think is called the p-test. Or p-series, I think is usually what they call it. And then, since this converges, okay, all I need to show, p-series, good. All I need to show is that this thing is less than this, which it is. Oh, the invite link? Oh, yeah, not the Discord. Yeah, here yeah, that's interesting why that died. Here, let me give you the invite link. Actually, good question. Who's in Twitch right now? I can just get to boost the server real quick. I need 2 boosts so that the URL just comes back. How about, yeah, just type that in the Discord chat. Whoever does it first, I'll give it to. If 1 and 1 is convergent, is always convergent. Yeah. So censor will give a rose. Okay. I saw it. Yes, I saw your question. So here, let me prove to you that it actually came up. Yeah, this is your question you submitted, right? We'll get to this one next. So this is 1 over n squared plus 2n plus 1. And this is always less than this, right? So I can say that 1 over n squared plus 2n plus 1 is always less than 1 over n squared, because n squared plus 2n plus 1 is always bigger than n squared, right? Because by definition, 2n plus 1 is always greater than 0. So n squared plus something is always greater than just n squared. So because this converges and this is always less than this, you can say that this also converges. And so this would be absolutely. Does that make sense? CD? What's up, Sensation?
What the hell does that even say?
What say?
If I and I is conv, it's always conv. What?
Oh,
I feel like I've had a fucking stroke.
You saying if 1 and 1? If 1 and 1 is convergent, is always convergent. Look height. I don't know what that means. Look height.
My fucking God, go back to school. Don't do maths, do English. Go now.
Maybe he doesn't speak English. He says it looks all right. Okay. All good. Okay, absolutely.
When I was 2.
Here, let me do if you hang around, Skeek, let me do this person's question real quick. Just because they asked, and I want to make sure I get theirs because they're on TikTok. And then I'll come back and do the rest of these. Is that cool? But that one's absolute conversion. You're good, Sensation. This one,
no,
if you want...
I didn't come to just abuse the guy. There was a point to this.
What's the point?
Twitch has gone offline for you.
Yeah, I just turned it off because it was frame dropping too much. I would rather people not have a bad experience on Twitch. So I just killed it. I'll try it again tomorrow and see if it's going okay. But Skeek, I would do the ratio test for this one. This one may end up being the root test. We'll look at it. And then this one, I think we may do an integral test. Because I think there's something about cosine of n pi over n. But we'll look at it. Let me help out Motion real quick. Your biggest fan, Motion. Hardest GCSE math problems. Oh, okay. This looks like a fun one. Cosine of n pi negative 1 the n might help. Yeah, exactly. Let me copy this person's in, and then we'll do his afterwards. Okay, Motion. Yeah, we're going to go through yours. Give me a second. The root test works for all of them. I like the root test. I think the root test is great, honestly. It's a very fun one. Waiting for this upload. Give me a sec. Okay, cool. All right. I cook on circle theorems, and you don't need. It doesn't need to point Kari for this. Okay. Oh, you're okay. Go. Wait, the actual Discord doesn't work? It should work. I checked it today. If you go to www.actualdiscord.com/submit, you should get something that looks like this, and this is where you can put your screenshot in. So, here, I'll paste it there for you so you can see it again, maybe. Should work on a laptop. Oh, it works on your phone. Okay.
Always fascinates me how you have a hard time saying GCSE.
GCSE? Is it GSCE? GCSE, right? GCSE.
And I'm just, you sort of trip over it slightly. It's really quite interesting just to listen to you say.
It's new for me, dude. Oh, yeah, I appreciate the rose. Thank you, dude. Can you maybe... So, what's the question here? Motion? What's the question? What are you asking me to prove? Riemann zeta?
Yeah.
Oh, this is a Riemann zeta function. It's about prime numbers. Okay. You may be educating me on something here, honestly. Let me read through what he put in Discord. Yes, I can do partial division too, Dino, if you need help with that later. Let me see. Reki, we will get to yours, don't worry. I want to make sure this is loading, though. Okay, this is okay. The circle one might be easier. Pretty sure it's a millennium question. Is that this one right here? Motion? Let me try to do this one. Just because I know there's probably an answer to it. All right. AB is tangent to the circle at point A. Okay, I agree with that. Cool. Point B has coordinates 16, 0. Point P has coordinates 3P, P. Find the value of P. Give your answer to correct to 1 decimal place. You must show all your work. Okay. So, from this information right here, I know that 3P, P is a point on the circle. And it's centered at the origin, right? So that tells me that x squared plus y squared must be equal to some radius squared. Okay. And if we were to plug in these coordinates in for x and y, that would get me 3p squared plus p squared is equal to r squared. All right. So that gets me 9p squared plus p squared is equal to r squared. So 10p squared is equal to r squared. So that tells me r is equal to the square root of 10p. That may come in handy somehow. I don't know yet. Okay. Now, what we know, right, is that if a line is tangent to a circle at a point, that the angle between the radius that connects that center to that point is also equal to 90 degrees. Is that correct? This is an important theorem about circles, right? Good. So now this makes a triangle, guys. And more importantly, this is a very special triangle because if this is 30 degrees and this is 90 degrees, that means this must be 60 degrees. Okay? And what we know, right? So it's a 30, 60, 90, exactly, which is a special triangle. I know that one length of this triangle, which is the hypotenuse of the triangle, is equal to 16 because this distance is 16. Good. And now we know what the radii is because the radii here was equal to the square root of 10p. And all that's left to do is to do a little bit of trig here, in which I know that the sine of 30 degrees, which is here, is the opposite over the hypotenuse, which is equal to the square root of 10p, square root of 10 times p over 16. And the sine of 30 degrees is equal to 1/2. Right? So that tells me that square root of 10p is equal to 8. And so p is equal to 8 divided by the square root of 10. So 8 square root of 10 over 10 is what this is equal to. Because, sorry, what do they want? P value to 1 decimal place. Yes, n squared root of 2 and 2 times the length. Yeah. Yeah, for a 30, 60, 90. So there's a couple ways to do that one, actually. I like to do it with the hypotenuse being 1 motion. And then if this is my 30-degree angle, I make this one 1/2. And then I make this one the square root of 3 over 2. I know some other people like to do... It's like the 1, 2 square root of 3, but... I don't know. For whatever reason, I like the hypotenuse to be 1. I feel like it helps you out later in life. Okay. So yeah, this is done then. So you just have to do 8 root 10 over 10. So that's 8 square root of 10 divided by 10. Right, yep. Square root of 2 over 2. So that's going to be 2.5. So to 1 decimal place, I would say 2.5. Was that the correct answer there, Motion? Okay, yeah. 2.5 is correct. Nice. Good job. Very impressive. Well, no, that was a cool question. I actually like that one.
Well done.
I like GCSE questions. I do. Yeah, GCSE is cool. Yeah, more than happy to do those. Just keep submitting them to me. Let me help out. I think Recky Rec is next. He asked a question in our server. Yeah, exactly. There's a bunch of different ways to do this. For me, I also am abysmal at at circle theorems. Yeah, Recky Rec, you're up. Let's do yours, Recky Rec. And then I like that integral. That integral's a fun one. I'm gonna show you how to do that one. That's a fun one. Okay. Let's see Recky Rec's question real quick. Yes, Recky, I got you. Recky, we're gonna do your question. Don't worry. Okay, he says, solve each quadratic equation using any appropriate method. Express your answers in exact values. Justify your answer of choice. Okay, Joe. Yeah, we'll try it out. I see that integral. It's an interesting one. Yeah, so I think sometimes to factor this, the issue is I don't have numbers that multiply to 10 and add up to 4. Just doesn't happen. So, yeah, I believe what you have to do is just use the quadratic formula. Trusty it always works. Yeah. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You could complete the square, but it's not really... I mean, completing the square is better when you're, I say, graphing, like putting things into vector form, sorry, not vector form, into vertex form. That can be better. Okay, so this is negative 4 plus or minus the square root of 16 minus 4 times 1 times 10. And that's going to be all over spam. Does it say spam? I don't know. We'll see. This one doesn't have real solutions, P says. Okay. P127 says there's no real solutions here. And he is right, because 4 times 10 is 40. 16 minus 40 is going to be, negative 24. Right? This is all over 2. Yeah. So whenever you have negative square roots, you can take the negative out. You just got to pull an I out. Right. So you're going to have negative 4 plus or minus I times the square root of 24 over 2. Now, you can break down the square root of 24 into factors. So I can make this the same thing as 2 and 12, 2 and 6, 2 and 3. I got a pair of 2's that come out. 2 times 3 stays inside. So you have negative 4 plus or minus 2i square root of 6 over 2. And now here's the cool thing. Because each of these things is divisible by 2, you can go through and cancel that. So this is going to end up being negative 2 plus or minus I square root of 6. You're only allowed to do that. So here, some students would be tempted at this point to just divide this by 2 and pull it out. You can't do that. You got to make sure there's also something here that's divisible by 2. And so here we have 4 and 2. Those are both divisible by 2. You can pull out and get this. So, yes, they are imaginary. These are exact, but they are imaginary. Cool, nice. Does it make sense there? Recky, yeah? Good. You have an inscribed question I might like? Okay, let's see it.
Well done! Well done!
Okay. We have some more submissions that have come through. Let's see what these are. Recky might have gotten banned. How did he get banned on YouTube? He gets a little too happy with all the caps and stuff. Okay. All right. Well, he knows we're fine on his Discord. Here, let me. This is like a potato scammer. Potato scan. Okay. So this was x squared dx over 4 minus 2x plus x squared. And then I'm going to write this in exponential form. To the 1/2. Oh, wow. Oh, okay. Pre-calc is harder than Calc 3. It is sometimes. It does seem like that sometimes because the topics are like disjointed. Pre-calc, I say, is a grab bag of different tricks that you're learning so that you can do calculus later in life. Okay. So, I almost want to do partial fractions on this. Like, x squared plus 2x minus 4. Oh, that doesn't factor out nicely, does it? No. Okay, what if I say... What if I... Okay, I'm going to try this. I'm going to say that negative... Oh, this is weird. I'm going to say that negative x squared plus 2x plus 2 is equal to u. Let me just say that, okay? So then... x squared minus 2x plus 4, that's the same thing as negative u plus 6? Is that right? Right, negative u would make this positive, make this negative, and make this negative, which looks the same, and then you gotta add 6. Okay. And then that means that x squared is equal to negative u minus 2x. Right. Negative u plus 2x. Plus 2. Right? I think this might make things look better. Because now if I replace this... Oh, but I want things just in terms of u. Oh, ew. Oh, that's not good. Urgh. Because, yeah. This was looking like kind of fun. You had negative u plus 6, and then you had u to the 1/2. The problem is, like, now you have x's and u's. Usually, if you're going to do u sub and stuff, you want to get rid of all of the other variable. Okay. Well, I don't think I want to do that. And it's a shame, because usually if I see something and I see the derivative of it somewhere else, so for instance, if this was like x, then I could get really happy with this almost looking like ln. Because you have dx over x. But this is an x squared. Oh, man. Okay. Let's see. Anybody else have a strategy that they think they would use for this one? Complete the square in the denominator, maybe. You mean maybe complete the square in this one? They both have like xy minus 1 squared or something. Try linear substitution. X equals alpha plus beta t over 1 plus t. Determine an alpha and beta, and then solve the integral. Oh, okay. That's Desmal. That's an interesting one. So, okay. Let me see what Wolfram says for this too. If this becomes like something like super ugly, then I know we're at least like going down a bad path. Here. Wolfram Alpha is very powerful. What would Feynman do? He'd probably go to a strip club. Okay, this is already looking really bad. Bro, what? I don't think we want to do this. Yeah. This looks incredibly. These are other forms of the integral, by the way. Yeah. The fact that this question, by the way, is number 158 and looks like it was written with the tears of the old Soviet Union tells me this was probably like a very, very difficult integral. It's the sum of three terms. Was partial fraction used at some point? I mean, probably, right? I wouldn't... This does look like... Well, this is 4 terms. 1, 2, 3, 4... Sorry, 5. It's from a Russian book? Yeah, exactly. Yeah, the Russians were pretty intense with their math. This looks like 3 terms. You're correct. But this is hyperbolic inverse tanh. So hyperbolic inverse tangent. So tanh. And then... It's also using imaginary numbers and other things. Yeah. Try splitting the splitting I recommended above. Okay, what do you recommend? You go as dx over the square root plus dx over the entire denominator. Two x plus 4 dx. Is that how partial fractions work? For square roots? I didn't know for square roots. Plus 2x minus 4. Okay, so I think you were talking about... One sec. Okay, so I think... Was this the thing where we were saying let u equal to this? Let u equal negative x squared plus 2x plus 2? And then this, for instance, was... was equal to negative u plus 6, I think is what it was. And then x squared Yeah. Write the x squared in the numerator as 4 minus 2x squared, 4 minus 2x plus x squared plus 2x minus 4. Oh, okay, I see. Yeah. Okay. Actually, I kind of like that. This is cool. All right. So he's saying, let's say that x squared is the same thing as, this is kind of cool. We're gonna make this into something that looks like this as well. So I'm going to add 4. Yeah, so here we can add 4, and then we can also subtract 2x. So watch. Okay, 4 minus 2x plus this, and then what we have to do is subtract 4 and add 2x. So this is going to be 2x minus 4. This is also the same thing as x squared. This is a cool trick. This is similar to in completing the square, where we add and subtract the same number. I'm subtracting 2x, I'm adding 2x. I'm adding 4, I'm subtracting 4. Technically, we still have x squared. But now what I have is 4 minus 2x plus x squared plus 2x minus 4 all over 4 minus 2x plus x squared. Yeah, that is very sneaky, actually. And then this is 2 plus 2x minus x squared to the 1/2. And because you have the integral of a plus b over whatever c, this is the same thing as the integral of a over c plus the integral of b over c. dx, yes, thank you, sir. Don't forget the dx. I'm going to forget the plus c at the end. I know it's going to happen. Hey, oh, Bella. Yeah. Someone tell Bella there is a stream, but it's on YouTube and TikTok right now because Twitch servers are doing weird things. So here, let me give it to you, Bella, right there. Okay. So, yeah, now we can break this up into this integral plus this integral. So this is going to be the same thing as... And here, Bella, I might be able to... Let me see if I can still stream it on Discord. There you go. Tell me if that still works. We were getting some weird things with the frame drops, but I think it should work now. Yeah. Okay. Let me know if that works. Okay. So this is the integral of 4 minus 2x plus x squared all over this lovely mess. Plus the integral of 2x minus 4 over this lovely mess. And then dx, right? Yeah, you can see again? All right, yeah. Good, yeah. All right. Okay, the first one is an easy arc sine, he says. Okay. Let's see how that is an easy arc sine. So I believe what you're saying here is that, okay, well, I'm going to let u equal to... Oh, wait, this goes away, right? Isn't this the same thing? That's super nice. Yeah, this is the same. Okay, this goes away. So then you just have the integral of dx over 2 plus 2x minus x squared. 1/2. And you just have to complete the square on this one? Okay. I guess I could do that. So you want to complete the square on negative x squared plus 2x plus 2. So what I'm going to do is I'm going to move this over here. Divide by 2. Well, also, we got to pull a negative out, right? Yeah. Let me do that first. So negative 1 times, this is x squared minus 2x minus 2. Pull it away. Divide by 2. Add. So plus 1 squared minus 1 squared. Good, so that's -1, and then that's going to be x minus 1 squared minus 2. And then, there was still another -1 squared. So, yeah, that becomes 3 minus x minus 1 squared. That goes into this whole thing. So we have the integral of dx over the square root of 3 minus x minus 1 squared. Which, yeah, that is arc sine, right? Mm-hmm. Yeah. So, if we have, in this case, so this is another where we gotta do, say, u's and stuff, right? So, x minus 1 is equal to u. So, du just equals dx. That's fun. So then this whole thing is the same thing as the integral of du over the square root of 3 minus u squared, which is equal to the arc sine of u, which is x minus 1 over a. And in this case, a is equal to the square root of 3 plus c. Is that good, Decimal? Yeah? So that's what the first integral is. That one was nice. Okay. But then you've brought pain and suffering into my life. Because how am I going to do this one, dog? That's a sneaky trick. That's actually pretty cool. I like that for the first one. X minus 1z and then transform the integral accordingly, he says. Okay. Am I going to want to complete the square on both of these then? Is that what we're trying to do? All right, well, you know, actually, let's just do this. So let's take his little hint here. X minus 1 is equal to z. Okay. Then x squared minus 2x plus 1 is equal to z squared. Okay. So this right here is equal to z squared plus 3. Right? This is the same thing as saying z is equal to... Okay. So z plus 1 equals x. So then this whole thing is equal to 2z minus 2... 2z plus 2 minus 4. So this whole thing is 2z minus 2. And then, cool, dx equals dz. This is dz. And then this is negative z squared minus 1, right? I believe so. No, plus 4, I think. Plus 3. Yeah, thank you. Yeah, sorry. Plus 3. Okay, cool. All right, so coming further out. 3 minus z squared is from the other one. Yep, gotcha. Okay. So this is the integral of 2z minus 2 over z squared plus 3. 3 minus z squared to the 1/2 dz, which we can split into two further integrals, which is the integral of 2z over z squared plus 3 dz minus 2 times the integral of dz over 3 minus z squared to the 1/2. Put a plate on first. Yeah, there's a lot going on here. This is another U sub, right? This is so let's pull a 2 out. Actually, no, I like the 2 there, don't I? Because this is just the ln of z squared plus 3, right? Oh, I can't split the denominators. Oh, you're so right. Oh, I got excited there for a second. That was gonna be so easy. You're right. I messed up. Yeah, thanks. Can't do that. Fuck. I was getting so excited because this was gonna look really easy. I'm like, this is too simple. Yeah, definitely, JC. I can't split that. I screwed up. It's okay. I'm eventually going to get lost at, like, what variable we're on. I was splitting the numerators and the denominators, which you're not allowed to do.
You done messed up, AA Ron!
Can't do that. Okay. The first one, you can use the substitution. The square root of 3 minus z squared is equal to t. So now we have another... Dude, how many substitutions have we made? All right, thankfully, we have a new color here. I'm going to say... oh, TikTok died. 1 sec. I hate it when it does that. Give me a second. I got to restart TikTok. TikTok has like a timer on it. Oh, and actually, I'll leave it. There we go. That should be fine. Go live. Go live. Yeah, there we go. Okay. YouTube doesn't do this to me. YouTube doesn't get mad at me and say like, hey man, you're on the wrong. This was on your exam, dude? Excuse me? That's so mean. Activate the source. That'll go well. 1 second. Let me get TikTok back up. All right, TikTok's back. We back. Okay. All right. So you're saying here. T equal 3 minus z squared to the 1/2. Then t squared plus 6. No. Negative t squared plus 6 is equal to z squared plus 3. Not yet, Motion. We're still going through this one. Sorry, yeah, the TikTok crashed. God bless. Yeah, okay. Okay. And then... yeah. Well, is that 2z? I think that's just z dz is equal to dt. Oh, which, yeah, okay. And it's negative. Negative z dz. Oh, man. Oh, okay. Is it t dt? I don't think so. It's just equal to dt. I have t squared. Oh, for here I do. Wait, 1 sec. I said that this was equal to this, right? So if I take the derivative of both sides, that should just give me dt. This should get me 1/2 3 minus... oh, man. Oh, square the first? Okay. Oh, I see what you're saying. Yeah, okay. So t squared is equal to 3 minus z squared. Got you. Okay. So 2t dt is equal to negative 3z. Negative 2z dz. Got you. Got you. Yeah. Okay, so then that's that. Okay. So now I have the integral of negative 2t dt over negative t squared plus 6. And then that's times t. I think that's right. Now this is an easy partial fractions. Yeah, except this one's quadratic now, dog. So now I have... Man, I am running out of variables at this point, bro. Where are we? Because I don't want to start using x now. So, what are we going to say? So, negative 2t is equal to at plus b over negative t squared plus 6 plus c over t. Extract the minus from the bottom to get 6 minus t squared. Well, it's actually... I'm actually going to get t squared minus 6, right? Because wasn't this negative t squared plus 6? This minus would get me t squared minus 6. Right? Oh, yeah, duh. Sorry, my bad. You're right. Actually, this can just go away, no? Right? Oh, so this actually isn't bad at all. Sorry, is this just the integral of 2 dt over t squared minus 6? Is that right, Desmond? Yeah. And then I believe this is just like, what is this, arc sine or something? No, that's if it's a squared plus u squared. Oh, I see. Oh, man. Wait, so this is integral. Yeah. I use group world is what I use. Is this hyperbolic inverse? Let's see. I think it's one of these. It's tanh. This is where the tanh came in, by the way. Remember I said there was tanh in this solution? Okay. So this is negative 2 tanh of t over the square root of 6. You have ln's. Well, I think I can just use tanh, no? Sorry, tanh -1. Thank you. And then t was 3 minus z squared to the 1/2. Oh, that's the definition of arctangent. Okay, cool. How many marks? This is a lot of marks. Because, bro, didn't we also define z to be something else? Yeah, and we said that z was equal to x minus 1. So this is really... x minus 1 squared, right? And that is just this part. That is just here. Well, cool. I'm glad we got the... So, we have an inverse sine. We have an inverse hyperbolic tangent. And then... I wonder what this one we were supposed to do. Can you do the same thing? The passing score was 55. The high score was 55, and it was me. Well, congrats. So you're the only person that passed? Yeah, dude, this is ridiculous. Okay. I'm going to leave this with this because I have to go pretty soon to go teach other people. But I appreciate this question. Thank you, Desmal, for like taking time to go through this with me. This is a nightmare of an integral, and I appreciate the patience. But yeah, like, holy shit, dude, what? Like, doing this and all the different techniques you had to use. It's cool. It's just a hell of a puzzle. Oh, okay. They let you redo it? Then yeah, that would make more sense. Okay. Here, let me try and do motions question real quick. And then I think Bella, did you have any questions that you had over your stuff, Bella? Let me text her in the chat here. Here, Bella. Did you need any help? You can find that book of integrals. It's called Lajasco 1. Let's see. Okay. Chapter 3 in the book. Well, I see 111 222 333. This almost looks like it's Polish? Or is it Hungarian, maybe? Ah, it's a Serbian translation. Wow. Well, I'm glad to know that. Oh, Bella, you need help? Oh, here. Come to the stage. Come to the stage. Come say hi. Oh, you're doing something right now. Okay. That's okay. All good. You'll send it later. That's totally cool. You can find the integral here. There should be a solution. Where was it? It was on 158, right? Bella, probably in the next 15, 20 minutes. But we also have streams tomorrow, if that helps. Let me see. Yeah, 158. I just want to see where this was. Oh, we skipped it. Uh-huh. Yeah, here it is. Wow. So the arc sign in there, I think we got the arc sign right. Was it? Did we had the arc sign, right? Yeah, x minus 1 over the square root of 3. Oh, wait, sorry. Cool. And then this, they showed was an ln. Oh. Oh, actually, interesting. Cool. That's the square root of 6 thing, yeah. Wow. Very cool. Evil circle theorems, master GSA. It is a monster of an integral. But it's like going to the gym. You're just like lifting a very heavy weight at that point. It's just, it's good for the soul. Okay, let me see what this question was from Motion. It says the diagram shows 3 identical circles inside a rectangle. Each circle touches the other 2 circles and the sides of the rectangle. Okay, the radius of each circle is 24 millimeters. Work out the area of the rectangle. Give your answer to 3 sig figs. Okay. Well, if this is 24, then this is also 24. Oh, no, I appreciate it, Desmond. Thanks for coming by. No, they were fun. It's a good review to, like, you know, test out my... It's like going to the gym and just lifting the heaviest weight. Cheers, dude. Yeah. Okay. Motion says no. Am I not allowed to do this? I feel like this is okay. Is this not okay? Am I not allowed to say this is 96 motion? And then, I mean that should be okay. Saying this is the height though, that's not gonna be cool. I understand why that won't work. It looks like a contest question. Yeah, maybe. Well, let's see. I know this is 24, and this is going to be 24, right? You can give your proof after this? Okay, cool. Right? So, I mean, this is 24. This is 24. This is a GCSE question. You remember it? Oh, that's cool. Well, we got one of the dimensions. We just need the other one. It was one of the hardest ever, genuinely, yeah. Oh, yeah, you have to pay for this one, Motion. Yeah, it's not free, unfortunately. But I've heard, like, Microsoft has some free ones that aren't bad. Okay. Well, okay. I know this is 24, right? And then I know if this side is equal to this side, which is equal to this side, that all of these must be 60 degrees, right? Yeah, and I agree with that. Which, okay. This is another 30, 60, 90, no? Because now I know this distance. Right? That we can figure out. Because then I know this is another 24. Okay. This is 24. That's 24. Just got to figure out the purple, which is a 30, 60, 90, right? So here we have this being 24. This being 48. And then if this is 1 and then this is 1/2, then this is the square root of 3 over 2. So the purple amount must be 24 square root of 3. Is that right? So I have 48 plus 24 root 3 is equal to this whole thing. In America, what grade would this come under? I mean, honestly, this actually would not be asked. This is like a math challenge question. This would not be asked in a standard class. Because I don't know, it's more of like a trick to do this one. Yeah. Okay. So then we just do this times 96. Yeah, this wouldn't be really asked. This is kind of like just kind of a tricky question. Yeah, 1, 2 square root of 3 is, yeah, 24, 48, 2 square root of 3. Yeah. All right, so then we got to just use a calculator. So that's 96, and then I'll see P127 got an answer. Let's see what he got, and then we'll check it. So 48 plus 24 square root of 3. And dude, that's a very big, 3 significant figures. So I get kind of a big number. So we got this, which is big. But to 3 sig figs, that's going to be 8560, right? Or, yeah. Yeah, I would say 8.56 times 10 to the 3. Oh, and that was in millimeters. Millimeters squared. You did centimeters squared? Why am I multiplying by 96? Length times width. Yeah, right? So this side was 96, and this was 48, plus 24 root 3. So, yeah, I think that's right. In terms of, yeah, you take a, don't you take a, you take a 10 to the second, so it would be 86, it would be, I think 85.6 centimeters squared is what I would get. Yeah, it's EDXL. Okay, cool. What's up, P127? What do you want to say? Because I realized I had square millimeters, right? And then you went to square centimeters.
Not what the calculator says.
Oh, am I messing up already? Oh, bro, yeah, you're so right.
Yeah.
Dude, why did I put 8.56? Dude, that's so wrong. My bad. Thank you, dude. I appreciate that. Yeah, this should be 860, right? Or it should be 860, no? Yeah, which your 86.0 is much better. Okay, cool. I like that. Yeah, I messed up. It happens sometimes. 3 sig figs is 3,600 millimeters squared. You linked a harder one. Okay, well, let's see the harder one you said. Oh, I know this one. I've done this one. We've done this one before, I'm pretty sure, too. It's a rhombus? Oh, man, I don't know if I want to do a rhombus right now. Okay, 3 circles, each of radii 4. The center of the circles are A, B, and C, such that ABC is a straight line. Okay. Oh, man. Okay, work out the total area of the 2 shaded regions. So this is always where I'm just going to figure out one of these and then just multiply by 2, right? So let's just focus on the top. Can I do like arc length and stuff? So each has a radius of 4. You want me to use rhombi? Really? What if I don't want to? Because, wait, I know this is 4, right? Oh, man. I feel like I want to like take this and then get this. What's up, Bob? Yeah, the YouTube gets a lot of subs. It's from all the shorts I post. Trapeziums. Give your answer. So when they say answer in terms of pi, this makes me think we want to start using arc length. Or like a sector. How's the UCLA lecturing going? It's good, dude. Yeah, today was the 2nd week of teaching. I think it went pretty decent. Wasn't too crazy. We'll see when the first exam happens how much they start complaining. Okay. Because okay, if I were to take the whole thing here, right? That would be 16 pi. So we have 16 pi is this whole thing. And then I want to try subtracting. I want to try subtracting like this. And actually, yeah. Let me just do this. I'm really going to like, we're just going to do this. We're going to do 4 pi. Or, wait, pi. Yeah, that's 4 pi. Yeah, equilateral triangles. I believe so as well. Okay. So this whole thing would be 16 pi, but we're only going to look at a quarter of it. So I'm going to say 4 pi. Would be equal to this whole thing. So, I want to figure out what this is, and then what this part is, right? So, if this is 4, and then this is also 4. Oh, arcs. Oh, you can't do it with arcs? Oh, really? Because I already know this is a... those are the same, right? And then this is also 4, right? This is an equilateral triangle, right? That means this is 60 degrees. Okay. So 60 degrees is 1/6, right? So I can say that 1/6 times pi times 16. That's going to be equal to all of this. And then we need to add in this part, which the blue part is this something with a triangle? It was going viral in the UK a while ago. Oh, that's so interesting. Oh. Oh. Yeah. Okay, that's equal to 1/6 pi times 16 minus the area of the equilateral triangle. Which, isn't there an easier sorry, I'm kidding. I'm just getting tired. I just want the equation at this point. There's one with the side. Okay. Yeah, square root of 3 over 4 a squared. Okay, this is what I wanted. I just wanted this. We're hitting the the almost 2-hour mark at this point. Well, this works as well, right? So this is just going to be square root of 3 over 4 16, right? Because then that's the area of the whole triangle. Okay, so let's try to put everything together here, like what's going on. So we have one of these plus another one of these. Okay, so that's 1/3 16 pi minus the square root of 3 over 4 times 16. So that's 4 square root of 3. Okay. And that is equal to the area of 16 square root of 3 over 4. Yeah, so if you do 16 divided by 4, that gets me 4. And I could just skip 4 square root of 3, right? You're expected to do this in 5 minutes? No way you can do this in 5 minutes. Do what? That's nuts. Okay. Alright, so that's what this whole thing is here, right? This whole thing we made is this. Well, are you supposed to prepare for this one? I don't know how you would do that, man. Okay. So then I'm going to do 4 pi minus that thing times 4. So 4 pi minus... So, because remember, 4 pi is the area of this thing. And if we subtract that, we get this. And then we multiply it by, because there's 4 of these things. I think you could get a 9 right now. Is that good? I don't know. So 4 pi minus 16 over 3 pi plus 4 square root of 3. All times 4. So, what is that? 4... Negative 4 pi over 3 plus 4 square root of 3 So 16 root 3 minus 16 pi over 3. So what? 48 root 3 minus 16 pi all over 3. (16 over 3 pi) 16. Yeah, nice, cool. I love that. That's yeah. P127 got the same answer. Cool. All right, nice. Love that. That's a good question. Yeah, Motion, was that the answer? Was this it? P127 got the same answer, and I'm assuming he's pretty correct. But man, yeah, what a mess of like solving things. 16 square root of 3 minus 16 pi over 3. Yep, that's what we got right here. Cool.
My man.
Nice. Okay. Cool. Glad we got it. That's a good question. Okay. I'm gonna end the stream off because I gotta go run and teach someone else. But I hope you guys found this useful and helpful. We stream 3 times a week. So so this time 3 p.m. Pacific starting. Tomorrow will be 4 p.m. Pacific starting, and then Wednesday will be at 5 p.m. So yeah, thanks for coming on by. Please come by the stream throughout the week, and we're happy to help you guys out with questions. Okay, cool. All right, let's close the stream out. Thank you everyone for coming to office hours. Oh, I can't rate anyone because we're not on Twitch. Yeah. Anyways. Okay. Cool. All right. That being said, yes, thanks for your questions. Come on by tomorrow, and we'll help you guys out with more stuff. Have a wonderful rest of your Monday. Peace out.